everybody. We are making a tutorial video about EAS, a cloud computing model, in collaboration with Stephanie Hu, a student of MIT of Boston, which is a very prestigious school, University of America. And Einaudi Paredo is so proud to collaborate with her. Thank you.
I am from MIT, currently studying computer science as a junior. And today I will give a short presentation with an intro to cloud computing, platform as a service, and AWS. So cloud computing is the on-demand delivery of various services like compute power, database storage, applications, and other IT resources. But the catch is that it's through a cloud services platform via the internet with using a concept called pay-as-you-go pricing. So normally or traditionally, when developers develop new applications, they have to purchase all the hardware and infrastructure themselves. But with cloud computing, this is no longer necessary, and instead, an external provider provides all these resources. And instead of buying and purchasing all the infrastructure up front and having to estimate how much storage or how many computers that you might need, instead, you just, with cloud computing, you use as much as you need and you only pay for that much. So AWS is a service offered by Amazon that offers many cloud-based products. These are just a few of the areas that AWS offers services for. And to go a little bit more, these services are important because they help organizations move faster by providing already built infrastructure for the organization, as well as helping them to scale and lower their IT costs. Since Amazon is a large company that provides a large variety of services that cater to many customers, they're able to help each customer scale as well. Finally, many of these applications can be used for various different uses, including mobile and web applications, game development, data processing, and more. So here's a list of everything on AWS. If you go to their website, I won't go too much into detail since I think the documentation on Amazon's website is better. For example, for each category as well, AWS offers different options. So for example, compute, we have EC2, Elastic Beanstalk, container services, and more. These are some services for storage, security, and there are many, many more. So I think in the Erasmus course, the students will focus on only a subset of the services offered by Amazon, including EC2, VPC, IAM, CloudWatch, Cost Explorer, billing, and CloudFormation. So now, with AWS having been introduced, we now will look more specifically at PaaS, which stands for Platform as a Service. So a little bit of background. When building an application, developers must take care of many different components. For example, finding data centers to store all the data that their application uses, purchasing compute power to allow the application to process and to run, implement measures of security, so to keep the user's data and their whatever actions that they perform on the application to keep the privacy of their users is very important. Obtain servers to host the application, so obtaining a way to have the application move from locally on the computer, which is generally where people develop their applications, to like the rest of the world to see. So, for example, if we think about email, if we're trying to build an email server, we would have to find a data center to store all the data. So store information about users, their account information, as well as emails that they send to each other. Purchase the computing power to allow the emails to run and allow people to be able to access their emails. Security is important as well, so that the privacy and like the content of the emails is protected. And then, of course, we will need to get the email application from the local computer out so that the rest of the world can use it. So that is one example, a simple one for all the components that we need to think about when building what we might think is a very simple email application. And of course, I have not gone into everything, so there's many more things that one must deal with, which is a headache. This is how I look when I'm programming sometimes. But PaaS helps us solve many of these issues. So, Platform as a Service is a cloud computing model that makes it easier for users to develop their applications, deploy them out into the world, run and manage their software without having to think about the underlying layers. So, generally the underlying layers refers to the infrastructure, so like data centers, servers, GPUs, or other computers, as well as any development tools that a user might want to use when developing their application. So this is just a quick comparison of infrastructure as a service, which only focuses on providing infrastructure for developers, platform as a service, which adds on functions like operating systems and developer tools, as well as some analytics. And then lastly is software as a service, which is the idea of offering an entire piece of software to the developer. So as I touched on before, traditionally if we do on-premise development, which is the development of an application like by a developer locally on their laptop or their computer, and they don't use any services offered by external like cloud computing servers, the user will have to handle everything, among them servers, security, network, etc. But with PaaS, an external provider handles a lot of the underlying layers. So basically the entire red box is everything that the external provider can provide for the developer. And as a result, the developer can focus more on developing the application and the features that are custom to their application. Such as like thinking about what kind of data they want for their application, what kind of features they want for their application, and not thinking too hard about where they will host their application, how they will run their application, or where they can store the data for their application. So advantages of platform as a service is first, developers are only focused on developing their applications. They don't care about the underlying layer, and that helps save time and resources because you're coding more efficiently if you reuse code that has already been developed by external providers. And generally these external providers, because they provide the similar infrastructure for many different customers, we can ensure that their products are also like correct and that they work well. And so among them, some components that tend to be pre-coded are services for directory, security features, and searching. The pay-as-you-go model is very important because now with cloud computing, developers don't have to purchase whatever resources they need up front, and so they don't have to estimate how, for example, how many data centers they might need to store their data, and if they estimate incorrectly, if they buy too many, then they basically have wasted money. If they buy too few, then they have to go and figure out a way to add more like databases or data centers for their application. But with pay-as-you-go, you use as much storage as you need, and as you keep using storage, Amazon or some other external provider continues to provide that storage, and you only pay for whatever you use. Also, developers can work together from remote locations because cloud-based services are in the, you access them via the internet. And so sometimes developing an application requires all developers to be working in the same location and be physically close to, for example, the servers or the data centers. But with the cloud computing model, because everything is on the internet anyways, the developers can work from any location in the world, basically. Some examples of platform as a service. I introduced AWS already, but Google, Microsoft, and Oracle also have their own cloud computing services. There's also Heroku and OpenShift that focus more on deployment of applications instead of full stack integration. The main differences between these different services are the features that they offer to the developer, pricing of their services, as well as how much autonomy and flexibility a user has, for example, when setting up or when using these services. So I think in the Erasmus course, OpenShift is the main PaaS service that will be used. So I will give a quick introduction about OpenShift. So the idea is that traditionally, when an application is implemented, it's a single set of libraries and configuration files on some operating system, whether it's like a physical or virtual server. So there's a couple of disadvantages with this. The first is that if the operating system updates, it will interrupt the application, and that's not necessarily good because, for example, if the application is like an email, you always want to be able to check your email, and if that service is interrupted, then I'm certain that people will get very frustrated. And the other disadvantage is that if you have multiple applications running on the same system, if the library of one of them updates, it could potentially affect the other just because they're all on the same system. So what we want to do instead is develop a high availability system that minimizes the downtime of an application. So what that means is that we have a system that always manages to be available at every given moment of the day, and so that the amount of time that the application is not functioning is minimized. This can be accomplished via containers, and that is the whole basis for OpenShift. So a container is a partition isolated within a single operating system. So what this means is that it's its own runtime environment, basically, and we can kind of think of containers as their own separate, not necessarily computer, but just a partition of the operating system. So traditionally, we see that we have our operating system and all the libraries are together, basically lumped together in the operating system. And then the applications are built on top of the operating system. With containers, we separate out the different applications so that the libraries that are associated with each application are isolated only with that application in that container. And so this allows us to better modularize our applications, which has many advantages. So, for example, the idea of containers is similar to virtual machines in the sense that we're trying to isolate components of the operating system, but containers, the way they're implemented, requires fewer hardware resources, but provides similar benefits as virtual machines. Containers are quicker to start up and to also stop them. They isolate the runtime environment. They're quick to deploy, so oftentimes services will just allow you to take the container that you already have, ship it off to the service itself, and then it will go be deployed without much additional effort from the developer. Many components are reused, and the impact of errors and changes among, like, for example, the libraries or the OS can be minimized. So OpenShift, finally, is a service for platform as a service developed by Red Hat that allows developers to focus on application development. It uses Docker and Kubernetes. I'm not sure if I pronounced that correctly, but it uses those two services internally. And so this allows developers to deploy applications in different environments, for example, development and prod. So prod is the environment that goes to production, so the environment that the rest of the world sees, and the development environment is what the developer can use to develop new features and test new features before they ship it out, new changes to the rest of the world. Facilitates continuous integration and can be interacted via multiple ways. So a web application, command line interface, or an API REST are all ways that a developer can interact with OpenShift. So now a quick explanation about Docker and Kubernetes. Docker is a system for virtualization that allows the developer to more easily create, deploy, and run applications. And the idea of Docker is that it uses containers, or it allows developers to work with containers. And so these containers are self-sufficient, so they don't necessarily have to depend on other containers to function correctly, although it's possible to have containers depend on each other. Multiple containers share the same core of the physical hardware, but each container can be restricted so that they only use a restricted number of resources, and so that better ensures that applications won't hog all the resources of a computer when we want multiple applications to be running on that computer. Kubernetes focuses, instead of creating and running applications, is more on the deployment, scaling, and management of applications. But Kubernetes also uses containers. So the idea is that there is a set of servers where the containers are executed, and the real applications are formed by several containers. So now that we have an application with all these containers, we can use Kubernetes to deploy, and also it helps automatically with scaling. So as the application grows bigger or more users start using the application, the system makes it easier to allow the application to grow. And so it provides other mechanisms to manage the containers, such as implementing, error tolerance, as well as integration and continuous updates. So there are many technologies available on OpenShift. So some database applications are MongoDB and Postgres. Some languages that might be familiar are Python and Ruby. And then Node.js is often used for web development as well. So I have not worked with OpenShift, but I've worked with Heroku in the past. And this is an example of a website that I developed using Heroku for deployment. And so the idea is that I could focus on only programming the parts that are important for the application. It was a task managing app, so the only code that I personally had to manage was code to implement the features of the managing app, a couple of security features, and then also the code for the HTML and CSS to design the web page itself. But then Heroku did the rest, so it allowed for deployment. It provides a server to host my application, as well as many other things. And the nice thing about Heroku is that it works much like GitHub, so we can just create a Git repo in Heroku and then push to that master branch. And every time we push, that basically is the equivalent of deploying an application. So it basically just makes the whole process of deploying an application streamlined and much easier. And so that's the whole idea of using these different services, platform as a service, to build applications. Thank you very much.